Hello, AP Stat students. Today we are discussing outliers and influential points. So we've looked at outliers before in quantitative data. Today we're going to look at outliers and how they are related to regression. Okay, so a regression outlier are points with x's or y's that are far outside the pattern of the data. Points can be outliers in the x direction, the y direction, or both. Okay. Influential points are points that change the relationship between our variables in a meaningful way. And influential points can be outliers. Okay. So to determine if a point is influential, perform the regression with the point included and without the point. Compare the associations. If the slope, or r, change dramatically with and without the point, then that point is influential. Okay. So basically it would require you to do two regressions and then compare the results with and without the point that you think might be an outlier. Okay. There are three types of unusual points or outliers that we will look at. The point is circled and it's in red on the screen. Okay, so the first one is right here. I circled it with the green pen. This type of unusual point can weaken the overall strength of the relationship, lowering the correlation value r. It typically does not change the position of the regression line or the slope in a dramatic fashion. Okay, so notice that with this point, that the y value for that point is pretty far away from the y values of the other points at that position. Okay, so we would call that an outlier in the y direction. Okay, where the y of that red point is just a little bit higher. If you look, it's about 20 points higher than the other values for that x. Okay, now that red point's not going to have a huge effect because of these points that are in the middle that are actually in line with the rest of the correlation. They'll balance out that outlier. Okay, so that outlier will have a minimal effect. So that's an outlier, but it's not super influential. In our second picture, you'll see here's the point. This point is an outlier in the x direction because you'll notice most of the data have x's between those two green lines, but this piece of data has an x that's pretty far away from the rest. So this type of unusual point can improve the overall strength of the relationship, raising the correlation value r. It typically does not change the position of the regression line or the slope in a dramatic fashion. So, imagine that point is actually in line with the rest of the relationship, right? It just has a very far x value compared to the rest. So that actually improves the correlation coefficient, it gets it closer to 1, but it really doesn't change the position of the line. Okay. The third type of unusual point, this has the greatest effect because notice it's an outlier in the x direction, and if you followed this pattern, that dot should be way up here, but it's not. So it's also an outlier in the y direction. These are the type of outliers that have the greatest effect. Okay, it weakens the overall strength of the relationship, lowering the correlation value r, and it can typically change the position of the regression line and the slope in a dramatic fashion. Points that change the least square regression line and correlation dramatically are said to have high leverage. Okay, and it's these double outliers, the ones that are outliers in the x and the y direction, that have the greatest effect. So here is an example, going back to the first example on the previous page, where we have the outlier in the y direction, right? Because it has a y that's bigger than a typical y for that spot in the data. We said this doesn't have a huge effect, so what we did was, you can see the picture on the left, that point is not included. Okay, and the picture on the right it is. So without the point, we figured out the r value, the r squared in the equation, and with the point included in the data, we figured out the same three things. So notice, without the point, the r value is a little higher than with it. Okay, And I think that makes sense because that red dot is not, it's not close to the prediction line, right? The prediction line would be going through here. So that's going to lower the correlation coefficient. Same thing's going to happen with r squared, obviously, for the same reasons that the r was reduced a little bit. But notice the equation itself, not much of a change. A little change in y-intercept, but if you look at the slopes, they're basically the same, okay? So that point didn't do a lot of damage, okay? With it, we lose a little correlation coefficient, we lose a little r squared, but the equation for the line really doesn't change. So predictions would be pretty similar in either situation, okay? Now, when you can see here in this graph, the solid line is with the point, the dashed line is without the point. So you can see they're basically the same. Like we can't really tell the difference. Okay. So bottom here it says the dashed line on the graph is a regression line without the added point. The two lines are approximately the same. The correlation R value does decrease with the added point included. Okay. But as far as predictions go, it's not going to have much of an effect. Here's our second example, where remember we had the outlier in the x direction. Okay, but the y is right where basically where it should be because it's on that regression line. And then the graph on the left is without the point. So this is without. This is with. So we did the calculations again, and you can see without the point, our R was 0.9865. With the point, it's 0.9886. So this increased a little bit, okay? It made the relationship appear stronger. And you can see our R squared value, it raised that as well. But you can see from our equations, the slope ended up basically the same again, okay? Very similar. So our prediction would be very similar either way, with the point and without the point. So what that point really accomplished was it raised our measures of strength and our coefficient of determination. So on our picture here, the solid line on the graph is the regression line with the added point, and the dashed line is without it. You can see that the point does pull the line down just a bit towards the point on that end, okay? But not really much of a difference. So, either equation would give you basically the same prediction, okay? So that point is not super influential. Here's the third example. This is the one that has the outlier in the x direction and the y direction, okay? These are the ones that have the most influence. So the one on the right is obviously with the point included. The one on the left is without the point included. So you can see without the point, it has a very strong correlation and a very high coefficient of determination. With the point included, you can see the correlation dropped dramatically, and the R squared dropped as well. We went from almost 100% of the variation accounted for to basically a little over half of the variation accounted for. And you can see the two equations, the slope changed by a ton, and the y-intercept dramatically changed too. Okay, so this point is influential. And we'd say it has high leverage. Okay, so you can see from the picture here, the solid line is with the point, the dashed line is without it. You can see that the point really has pulled the line dramatically towards it. Okay, and that's why we call it leverage, because it actually moves the line towards it. Okay, so these two lines are not going to predict the same value if you plug in an x. So we have to be careful when we have outliers like this, okay, because they dramatically can change what's happening. And we should make sure that that point is really valid. Maybe someone typed in the wrong number, maybe somebody played a joke on us, or they lied on the survey. We'd really want to make sure that that point's a valid point. Okay. So anyway, that red point is very influential. There are a couple videos, a couple other videos attached to this lesson that are really good that you should watch for just a little more information on this topic.